fourth space is the left null space of a matrix. It's kind of like a second-class citizen, and it doesn't get the respect it actually deserves because we haven't learned enough about machine learning, etc., to understand its significance well enough at this point. But for the sake of completeness, let's just go through this, and maybe I'll just highlight what it means. So the left null space is like the null space, but for A transpose. We know that the column space is a C of A, the linear combination of the columns of A, and the row space is the column space of A transpose. The null space is a solution to AX equal to 0, and then similarly you could have A transpose Y equal to 0 or possible Y's of that kind, and that would be the left null space. Now, as you can see, left null space is the null space of A transpose. For that reason, it doesn't really require a special treatment. Now, if X is a member of the null space, then it gets transformed to a B that is 0, which of course is a member of the column space because 0 is a member of all subspaces. So null space will transform to 0 vector. If X is not in the null space, then AX basically says some linear combination of the columns of A that will end up in the column space of A because it is a linear combination of the columns. So not in null space means column space, and all other vectors can be written as having a component in the row space and the one in the null space. And as you saw, A times the component in the null space will go to 0. So this becomes AX parallel, which is this, and X parallel is a member of the row space. Now, what that means is that we have accounted for all the vectors in the input space in Rn. There's nothing left in Rn to go anywhere else. So nothing goes to the left null space by the action of A in the input space. That doesn't mean that the left null space is empty. It just means that take any vector on the input side Rn, apply A, it'll always end up in the column space. A large part of the output space, Rm, may not be reachable by the action of A. So don't think of a left null space as being empty. It's not. It is highly non-empty, but there's nothing that goes into that space from the input side. Nothing gets mapped there other than to the 0 vector of left null space. Nothing goes to the left null space. So this statement, when I made it some time ago, it meant to some of my students that left null space is empty. So let me reiterate. It is not empty. It's just that the action of A on any vector on the input side cannot take that vector into the left null space. So left null space in blue is a set of all solutions of the kind Y, A transpose Y equal to 0. Some people in literature, they write it like this. We won't, but just wanted you to be aware of that. Just taking the transpose of that equation. The left null space is the same as the right null space. Well, right null space, nobody calls it right null space, it's just the null space. Left null space of A is the same as the null space of A transpose. It's a subspace of dimension M minus R. And for that reason, M minus R is called the right nullity. Why is this M? The matrix A was M by N. So the matrix A transpose is N by M. It's got N rows and M columns. If you do RREF on A transpose, out of the M columns, R of them will have pivots and the rest will not have pivots, M minus R, and that would give you the dimension of the null space there. And that null space is a null space of A transpose, which is the left null space of A. If I ask you to compute it, you have to say that the left null space is a subspace of Rm and its dimension is M minus R. So the left null space is a subspace of Rm with dimension M minus R. And the basis vectors would be the special solution of A transpose, not A. So if I give you a matrix A and ask you to compute its left null space, the first thing you would do is to transpose it, and then you would proceed to compute its null space, which would be the left null space of A. The next video is going to be significant. It's kind of wrapping up these 4 fundamental spaces, and with some kind of review to highlight to you how these things tie in with the rest of the things that you have learned so far.